Regula Falsi, or the false position method, keeps a guaranteed bracket like bisection but converges faster by using the function values at both endpoints. Instead of the midpoint, it draws a chord between the two bracket points and steps to where that chord crosses 0. Bisection always picks the midpoint, ignoring the function values. Regula Falsi draws a straight chord from A to B and takes the x-intercept of that chord as the next estimate. The bracket always remains valid, but one endpoint often stops moving. When the function is convex or concave throughout, the chord keeps hitting the same side and convergence stalls. This is called one-sided stagnation. Despite stagnation, Regula Falsi is faster than bisection on well-behaved functions and remains a robust fallback when derivatives are unavailable. Watch the three chords. The first connects the full bracket from 1 to 2 and lands at xr equals 1.333, already much closer to root 2 than the bisection midpoint sitting back at 1.5. The second chord moves to 1.4, the third to 1.412. But the right endpoint B stays locked at 2 throughout. That is the stagnation effect. A increases, B does not. Apply Regula Falsi to g of x equals x squared minus 2, whose root is the square root of 2. The initial chord from 1 to 2 crosses at xr equals 1.333. G of xr is negative and g of a is also negative, so a moves right, but b stays fixed at 2 for every step. This is one-sided stagnation. The lower bound keeps climbing toward root 2 while the upper bound b never moves. That is classic Regula Falsi stagnation. In EES, define two bracket update functions. Rf underscore low returns the new lower bound. It computes xr from the code formula, checks the sign condition, and returns a if the root is in the left subinterval or xr otherwise. Rf underscore high is symmetric. It returns b if the root is in the right subinterval or xr otherwise. The duplicate chain then calls both functions each step, narrowing the bracket automatically. The Colebrook equation for the Darcy friction factor is implicit in FF. With Reynolds number 100,000 and relative roughness 0.0001, we bracket FF between 0.005 and 0.1. Note that A never moves from 0.005, another case of one-sided stagnation on a monotone function. The upper bound moves down each step, but A stays fixed. After 10 steps, the friction factor converges. First, define the Colebrook residual function g underscore cb using an intermediate variable to keep the line short. Then define rf underscore low for the lower bound update, calling g underscore cb inside. Rf underscore high is symmetric to rf underscore low. The duplicate chain runs 10 steps. Inspect xr of 10 in the solution window to read off the converged friction factor. Regula Falsi. Week 1.